Hello once again. Welcome to Math 110. It's intermediate algebra, and we are working on chapter 10, in particular 10.2, where we're talking about rational exponents in this section. Rational meaning the ratio that involve exponents. So something like x to the 1 over 3. Okay. Okay, so far we have only worked with integer exponents, meaning something like x to the 5th power. In this section, we extend exponents to rational numbers as a shorthand notation when using radicals. And that again means x to something similar to x to the 1 over 3. The same rules for working with exponents will still apply. And that's all our properties for exponents. And what were some of those? We had the product rule, where x to the 3rd times x to the 4th equals x to the 7th. We had the power rule. All these rules applies to rational exponents. The power rule was given as x to the 4th. These are all examples. I'm just willy-nilly taking them out of my thoughts here. X to the 4th raised to the 2nd is x to the 8th. You multiply the two exponents in this case. We also had the quotient rule. Quotient rule. I guess I'll write the word rule here. And that works as what? X to the x over y in parentheses raised to the 3rd power. So that would be x to the 3rd over y to the 3rd. Using the quotient rule. Or another one too, I could say. The general quotient rule would be x to the 5th divided by x to the 3rd. And the quotient rule is 5 minus 3, which would give you x to the 2. Okay, so that's the general rules for the exponents, and we'll come across others that we'll talk about when we get there. All right, next screen. All right, here's our definition of a to the 1 over n, the rational exponent, and this is really it really gets into some fun problems to solve for when we're dealing with this. If n is a positive integer greater than 1 and the index of square root of a is n, is a real number, then a to the 1 over n equals this. And now you want to form your way of when you get a to the 1 over, let's say it's 2, then this is the same as the square root of a. Notice where that index goes. The denominator goes over into and becomes the index here. That denominator, which is 2. So if I wrote this up a little differently, just so you get the idea of how you form these from a rational expression, rational exponent, into the square root form. So if I wrote this up as a, this is a little different, a to the n numerator divided by d, the denominator. And this is going to equal then the square root, not the square root, I should say the d root. So d is coming here, that's your denominator, whatever number that is, and then it's going to be raised by a to the n. So up here, if you notice, what did they do? We have a to the 1 over n. The n kicks out to be the, what's that word? My God, I can't think of the word. Think of the index number, there it is. and it's raised to the 1 power, but we don't write the 1. Okay, so remember this form here if that is a little easier to help you. Okay, we got some examples coming. Okay, here's some good examples. It says use radical notation to rewrite each expression, simplify if possible. So radical notation means using the radical sign, and the radical sign is the square root sign. So I want to take this and write it in radical notation. All right, so this 81, and notice what I said earlier. I mentioned that a to the n, numerator divided by denominator, would equal the d root of a raised to the nth power. Okay, so for 81 and a fourth, it would be, this is going to be the what root? The fourth root of 81 to the first power, but I don't have to write that. So now I want to look for what is the fourth root of 81. So now we go little sidebar, write our 81 here, and do the prime factorization. So here I know it's 9 times 9, and then 9's break down to be 3 times 3, and 3 times 3. How convenient is that? So that means for every 4 3's, you take out 1. So this ends up equaling 3. The fourth root of 81 is 3. Let's do the next one, 64 and 1/3. So that must mean this is the cube root of 64 raised to the first power. So I'll take my 64 now and do my breakdown. We'll on the sidebar again. I'm thinking 8 times 8 is 64. The 8, there's the 8 again. How many 2's is that? Right, 3 of them. So I got 3 2's for this 8, and I must have 3 2's for this 8. So for every, 3 2's, I take out 1. So here's 3 2's here. So I'm going to take out 1. I'll put my equal sign. And multiply to a second set of 2's. For every 3, take out 1. So that means the cube root of 64 is 4. And again, because 4 times 4 times 4 is 64. All works in a nice cycle there. All right, how about C, x to the 1 over 4. So I'm simplifying this. This is going to be the fourth root of x. And I reckon that's all I can do with that one. That's it. That's simplified. What's going on there? So this is simplified and it's done. Okay, next screen. Okay, what do we got? More of the same here. For D, use radical notation to rewrite each expression and simplify if possible. So this first one, I got a negative 16 raised to the 1/2 power. So I know my index is the square root, so this is going to be negative. I'll write my negative sign here, and then I can put my radical sign up. And how about this? It's going to be 2 is here, the square root, so I really don't have to write the 2. You can if you want. Let's do it if you like, because just the plain square root sign means that the index is 2. It's not written. Okay, and then I know it's raised to the power. What is the 16? So this is saying what's the square root of 16? Well, we know that to be 4, and then the negative comes along with our answer. So it becomes -4 because of that negative sign. Okay, how about this fella here? This is a case where we're using the power rule, right? This is a power raised to a power. All right, so now this is a product to power rule where I got to include the 32. So separately, I could write this to be 32 raised to the 1 over 5 times x to the, what's 1/5 times 10. 10 times 1 over 5 equals x to the 10 over 5, which simplifies to be x squared. Okay, so let's take care of this 32. This is saying what is 32? 32, I'll put my root sign here, the fifth root of 32. What is the fifth root of 32? And that's easy to do. I'll come up here and do it. Here's 32, and I'll do the prime factorization. What do I got here? 2 times 16 is 32, so this is prime. 16 breaks down to be 4 times 4, and 4 breaks down to be 2 times 2, and so does this 4, 2 times 2. So here I got all these 2's here. How many are there? Well, by coincidence, there's 5 of them. If I want the fifth root of 32, that means for every 5, I take 1 out. Well, here's 5 of them. That's all we have for 32. So taking 1 out gives me 2. And so putting the 2 together, I've got 2 and the x to the second power. This is my answer. Okay. How about... Okay, here we'll move on to F. And I've got this monster here I'm dealing with. So let's see here. I'm gonna break this up. Remember, we're writing it in radical notation. So I'm going to have what here? I'm going to have 16 raised to the 1/3 times x to the, and this is the power rule now, right? So this is going to be multiplied to the 7, so that would make it 7 over 3. Okay, good with that. So this is going to end up equaling, well, let's see, I've got the root sign, and my index is 3. And then what is the cube root of 16? So let's come over here and we'll write 16 up and do the prime factorization. And that's going to give me 4 times 4, which will give me 2 times 2 times 2 times 2. So I have these 4 2's here. For the index is 3, so for every 3, we take out 1. So I'm going to take out 1 and I'll put it in front here. And what? I got 1 left over, so that goes in there, and that's called the radicand. And now that'll stay underneath the radical sign. All right, we're good with that. So 16 is taken care of. And now I want to deal with this x to the 7 over 3. So that, again, means the cube root of x to the 7th power. And now I want to take the x to the 7th and factor that. X to the 7th. That's x times x times x times x times x times x. Got 1, 2, 3, 4, 5, 6. Whoop, one more. 7. And for every 3, I take out 1. So here's 3, and 1 is going to come out. I'll do it down here. Here's another 3. 1 comes out to make it x squared, and I've got 1 left over. So let's see, that 1 left over here is going to be under the radical sign, and this x squared is going to be squeezed in here, x to the 2nd power. So my final answer, I'm going to clean this up a little bit, is going to be 2x squared, the cube root of 2x. So this whole thing is my solution for letter F. Okay. Okay, here we are. Next set of examples here. Use radical notation to rewrite each expression. Simplify if possible. So it looks like it's more of the same. And here I've got 4. Let's take this. write it as we need it. So this is going to be rewritten in radical notation. So my index is 2, and it's going to be 4. And this, I guess you could write it as the whole thing, whatever this comes to, raised to the third power. That would be fine. And this simplifies to be the square root of 4 is 2, and 2 to the third power is 8. All right, we think that's okay. Square root of 4 is 2, raised to the third power is 8. That is interesting too. This is interesting. If I rewrite this, I could write it as, this gave me a little trouble, I remember when I was learning it, but it could also be written up as the second power, or the 2 there, the index number, raised to the 4, with the base of 4, raised to the third, raised to the third power. Having a hard time speaking all of a sudden. So if I did it this way, I could calculate what's 4 to the third power, and that would be the same as the square root of 64, and I still get 8. So I think it's a little bit easier. I think in times we will want to do that. We'll want to take the square root of the number and then cube it. I think that's a little easier that way. Square root, cube root, whatever the case may be. Anyway, let's go on to B. I've got negative 4 over 3, so that means it's going to look like negative. And since my index number is 3, that negative could go inside. I'll leave it as such. And it's going to be 8. And then we'll take the whole thing and then write it up as a positive 4. Okay, and what have we got here? So this middle part here is going to be the cube root of 8 is 2. So I have negative 2 raised to the fourth power, which gives me 16. Okay, I go along with that. And another one will be, oh, this looks different. What do you think about this? So I've got 3x plus 7, and that's the underneath the radical sign. The index is 3, and all of this is raised to the 7th power. Okay, so that means what? I've got to write this 3x plus 7 times. Let's see if I can do that. I don't have to. There's a little shortcut to this. 3x plus 7 plus 3x plus 7 plus 3x plus 7 plus 3x plus 7. So that's 1, 2, 3, 4. 3x plus 7. 3x plus 7. 4, 5, 6, and 3x plus 7. So there's 7 of these 3x plus 7s. And for every 3 from the index, I'm going to take out 1. So I got 3x plus 7. I got 3 here. So 1 comes out. 3x plus 7. And I've got 1 here and 2 more here. So that means another 3x plus 7 comes out. I'll just square it. And I've got 1 left over. So in our radical sign is the 3x plus 7. And then on the outside is this 3x plus 7 squared. Let's see. Well, I'll just rewrite it. How about that? I'll rewrite it going this way. So my answer looks like it's 3, that's a 3, x plus 7 squared And in the radical sign, it's 3x plus 7. And what's missing? Make sure you write your little index number of 3. Okay, now this guy here is my answer. Okay, that was that. Turn this off a second. Okay, how do you feel about this now? Now, to complete our definitions, we want to include negative rational exponents. Oh, great. Negative rational exponents. We remember that. If a to the negative m over n is a non-zero real number, then a to the negative m over n equals 1 over a to the m over n. So that's similar to when we had a to the negative 2, for example. This equals 1 over a to the positive 2. So that's what this is implying as well, only we have rational exponents. All right, let's see what kind of fun we can have here with these. All right, write each expression with a positive exponent, then simplify. Okay, so this first of all, I got to change to be 1 over 64 positive 2 over 3. That's how we change it to be positive, putting it in the denominator. And then to simplify this, I'm going to do what I know how to do with this 64 to the 2/3 and change it into a radical expression. So let's remember it's going to be 1. I'll put my answer over here. 1 over something. And let's take this 64 and 2/3 raised to the 2/3. So it's going to be 64 under the radical sign. I've got an index of 3, and it's all raised to the second power. Okay, so the cube root of 64, if we remember, let's do a little work over here with this. So 64, I want the cube root of that, and I believe it was, let's see, I have 8 times 8, and this becomes what? 2 times 2 times 2 times 2 times 2 times 2. Okay. For every 3 2's, I'm going to take 1 out. Here's 3 2's, so I'm going to take 1 out. It is taken out. Here's another 3 2's, take that out. 2 times 2 is 4. So this becomes what? This becomes the cube root of 4. Well, it's 4. 4 times 1. So that's just going to be 4. And I square it. That's this squared here. So this inside here is 4, and then I square it, and it's going to be 16. So I end up with 1 over 16, and that's my answer. How about B here? B now. I could take this and say it is, I've got a negative here on the outside. And then if I'm going to write this is going to be negative 1 over 16 to the positive 5 over 4. Okay. Which is going to give me, now I'll concentrate on this 16 and 5 over 4. So let's see, what have I got? I've got 16 here. 4 is my index, and it's all raised to the 5th power. All right, what's the 4th root of 16? If you remember that, didn't I just do 16 up here? That was 64. Here's 16 then. 16 is going to be 4 times 4, which equals 2 times 2 times 2 times 2. Okay, so if it's the 4th root, that's going to be 2. So this ends up being 2 raised to the 5th power, which equals 32. Okay, so I've got 32. So this is all going to end up being negative, I can write it 1, negative 1 over 32. I just calculated what this is, and it belongs here. Okay. All right, moving on, we're going to use the properties of exponents to simplify. So I hope we remember that from I gave a little bit of the properties earlier, and so now let's implement them using rational exponents. So again, quickly, this would, if I had x to the x times x to the second, this would end up being x to the third using integers. But this is x to the 1/2 times x to the 1/3. So the rule applies that I'm just going to add the two exponents. So I got 1/2 plus 1/3. And remember how to do that. 2 times 3 is 6. Now cross multiply. 3 times 1 is 3. Plus 2 times 1 is 2. 3 plus 2 is 5. It's a nice little way of doing fractions with single digits. However, that's not our answer. It's x to the 5 over 6. Just so we don't get carried away. All right, how about B? 7 to 1 over 3 divided by 7 and 4 over 3. Well, let's see. I'm going to rewrite this, and I'm going to say I'm going to subtract the bottom from the top. So it's going to be 1/3 minus 4 over 3, which gives me 3 stays the same, and I've got 1 minus 4 is negative 3, which equals negative 1. All right, so what I'm saying is when you calculated this, since I subtracted the bottom exponent from the top, I end up with 7 to the negative 1. We have to change it to positive, so it's going to end up being 1 over 7 to the positive 1 if you want to write that 7 there. Okay. How about this one? Well, my bases are the same. I'm going to add these two. One happens to be a negative number. So I could say negative 4 over 7 plus 6 over 7. Denominators are the same, so it stays the same in this case. I'm going to add the numerators. So I end up with 2. So here I'm winding up with y to the 2 over 7. Okay, and that looks like that's it for A, B, and C. All right, here we've got another thing going. Let me get my pencil back. And the thick one. There we go. And we did D already, so let's concentrate on E here. And what do we got here? I've got, how about we do the numerator first, and then we will take care of the denominator. So let's see, using the product rule, I've got a to the 1/4 times a to the negative 1/2. So I add these together, which is the same as 1 over 4 minus 1 over 2. Okay, so that's going to give me 8, and 2 minus 4 as I cross multiply, if you're wondering how I'm doing this. This is negative 2 over 8, which simplifies to be negative 1 over 4. Okay, so here in my numerator now I've got a to the negative 1 over 4 over a to the 2 over 3. Okie doke, so now I can I can use the quotient rule here and subtract the bottom from the top or the top from the bottom. Why don't I subtract the 2 over 3, the bottom from the top? And let's see, so I'm going to have negative 1 over 4 minus 2 over 3. And that's going to give me 4 times 3 is 12. Cross multiplying, I got negative 3 minus 8. Okay, cross multiplying this way and then this way. Remember, my negative sign is right here. So I end up with negative 11 over 12. So officially, it's a to the negative 11 over 12, but I cannot leave it negative. The ungodly math rule. So that's easy to fix. I'm going to put it in the denominator as a positive, a to the positive 11 over 12. And make sure I put my 1 up top. So this is the answer to E. All right, here we are with some more examples. Use rational exponents to simplify, and then assume all variables represent positive real numbers. All right, so I want to use rational exponents to help me simplify it, then turn it back into a radical expression. All right, so here I've got, how would I change this? This would be the base is x, the index is 8, which is the denominator, and then the 4 is up front. So this ends up equaling x to the 1/2. All right, and we know then we could write this to be the square root of x. All right, so there's our first one. B is a little trickier here. If I wanted to, I could start this by writing it as 25 raised to the 1 over 6 power. And then, well, that doesn't do me much good. I could simplify this more somehow, and that would be by taking that 25 and writing it in exponential form, which that I am familiar with is 5 to the 2nd power. Okay, that's the only way you could do 25, right? So it's it's 5 to the 2nd power raised to the 1/6. Okay, doing so now brings this to equal 5 to the 2 over 6, which is the same as 5 to the 1/3. All right, fully simplified now. Doing it this way, so now in the radical notation, it could be written as the cube root of 5. And that's the simplification of this. It'd be interesting if you put this in your calculator where you get the same result. Let me try it. Let me try it real quick here. So here I've got well, no, I won't try it. Too many buttons to push. I don't want to keep you waiting. All right, but you can go ahead. Feel free to try it yourself on your TI 83, 84. All right, let's go on to our next screen. All right, looks like the last two here. And we've got use rational exponents to write as a single radical expression. Something similar to what we had done earlier. So let's try this. So I could write x, let me get my pen back again. Square root of x would be x to the x to the 1/2 times x to the 4 is our denominator, x to the 1/4. Multiplying these together, I add the 2, 1/2 plus 1/4. So that would be x to the 3 over 4, right? I'm taking the shortcut. 0.50 plus 0.25 is 0.75. In fraction form, it's 3/4. All right, and now if I write this in radical expression, it's going to be the 4th root of x cubed. Okay, and I believe that's satisfactory there. Let's try this next one, which is quite involved here. So I can write this to be, what could I write this to be? It's going to be 5. My denominator is 3. 5 to the 1/3 times 2 to the, well, it's just a square root, so it's going to be 1/2. All right, not much going on there. Let's get these denominators to be the same. This gets a little bit trickier. So, and you have to remember to do this. That's the hard part. It's like, what? It's like you feel like you can't do anything with this right now, but indeed we can. We can make these denominators the same by multiplying this fraction by 2 in the bottom and 2 on top. Remember, it's like multiplying by 1, so you're not changing it. And then this fraction will multiply by 3 over 3. So now, invariably, this changes to be 5 to the 2 over 6. 1 times 2 is 2. 3 times 2 is 6 in the rational exponent. And that's going to be multiplied times 2 to the 1 times 3 is 3. And 2 times 3 is 6. Okay, remember these are, I'm getting a little big there, but that's an exponent there. Okay, so now what can I do? I could factor out from this 2/6 and 3/6 a 1/6, and that would look like something like this. So I'd end up with, if I factor out a 1/6, I know this seems odd, but I'm bringing it out to be the, I'm heading for the power rule. And then if I put back what's left over, meaning 2/6 divided by 1/6 is going to be 5 to the 2nd power. Because when I multiply this 2 times the 1/6, I get 2/6 back, times 2, and what will that be here? 2 to the 3rd power. Now the power rule allows me going back this way here, which would be an equivalent expression. So look what I got. I got 5 to the 2nd power, which is 25, times 2 to the 3rd power, which is 8. So I end up with this being 200 inside. So can I scoot down here a little bit? Running out of room. So this is going to be 200 raised to the 1/6 power. And now in radical expression, I can write it to be this way. The 6th power and 200 under the radical sign. So that is this simplified in radical expression. Okay. And that is that. Done for now. Good luck with this section. Work hard, study hard, and it'll come to you. All right, goodbye.